For example, obtain the Fourier coefficients a0 and an for f of x equal to x squared between the interval pi and minus pi. Okay, we are going to use the concept of even and odd function. Okay, a0 equals 1 by pi times minus pi to plus pi, because interval is given as minus pi and plus pi. So minus pi to plus pi f of x dx. We know the expression for your a0 is given by Fourier coefficient is given by this. Instead of f of x, you have to substitute x squared. So x squared dx. So we have x cube by 3. Correct? You have to substitute upper limit and lower limit. Substituting the upper limit will give you pi cube. Substitute the lower limit will give you minus pi cube. So we have now pi cube minus minus, that will give you plus. So plus pi cube. So we have 2 pi cube divided by 3 pi. Correct? So this 3 pi. So we have now 2 by 3 pi square. So this is your a0. Simple one. And just now we discussed about f of x equal to x squared as an even function. Correct? F of x. So these are the conditions for even function. X squared is an even function. Cos x is an even function. Okay. So what I am going to do is, here this is ordinary one. Okay, ordinary one. What I am going to do is, we are going to calculate now an. Okay. So an is given by this expression. An is given by 1 by pi minus pi f of x cos nx dx. Instead of f of x, you just substitute x squared cos nx dx. Now look at the limit minus pi to plus pi. Sum is given as minus pi, pi to minus pi or minus pi to plus pi. So we have minus pi to plus pi. And x squared is an even function. Correct? Cos nx is also even function. Even function multiplied by even function will give even function. Okay, even function multiplied by even function will give you even function. So both are even functions. So now you can change the limit. For the even function you can change the limit. Now I am going to change the limit 0 to pi times 2. See here it is 1 by pi minus pi to plus pi. And this is an even function. This is also an even function. I am going to write this as 0 to pi 2 times. So 2 by pi 0 to pi. Is it okay? It's easy to integrate. So we have 2 by pi 0 to pi x squared cos nx dx. So this is okay. Now we are going to integrate now. The integration of x squared cos nx is very tedious. We are going to use Bernoulli's formula. So Bernoulli's theorem we are going to use. Bernoulli's formula goes like this. Integration of uv dx equal to, so one of the factors will be u, another factor will be v. So uv dx equal to uv1 minus u dash v2 plus u double dash v3. Okay. So here we have taken as u as x squared, vx cos nx. So u equals x squared. Here u dash is there in the expression. So u dash is nothing but differentiation of x squared. So u prime or u dash is nothing but differentiation of x squared. So that will give you 2x. Again when you are going to differentiate, u double dash, so that will give you 2. Again when you are going to integrate, differentiate, that will give you u triple dash, which is equal to 0. So we can't do after that. Only we can do only up to these 3 terms. So we have only these 3 terms. After that we can't do, because u triple prime becomes 0. So we can't do. Is it okay? Now similarly your v is here. v1, see here v1, v2, v3 are given. So v1 is nothing but integration. U dash is given is nothing but differentiation. So v1 is nothing but v dx. So v, what is v? V is cos nx. So cos nx dx. Easy to integrate. Cos nx is nothing but sin nx by n. And your v2 is nothing but, so there's a mistake here. It is cos nx equal to minus sin x. Okay. So there's a mistake here. So we have minus sin nx by n. So v2 is nothing but minus sin nx by n. So there's a mistake here again. So that's minus sign is missing. So we have minus sin nx by n dx, which is equal to 1 by n times. So minus sin nx you will have to integrate. That will give you minus cos nx divided by n. So put together that will give you minus cos nx divided by n square. Now V3 is, you have to integrate this. So integrating will give you minus 1 divided by n square. I have pulled out. So we have cos nx integrate, that will give you minus sin x. So we have that will give you sin nx divided by n. So we have minus sin x divided by n cube. Okay. So now we will have to substitute. Accordingly, we will have to substitute. So substituting, we will have this expression. So after substituting, you will have, we have 2 pi pi. See, 2 divided by pi, and this solution is nothing but this one. So u into v1. So u into v1. Then u prime into v2. U double prime into v3. So we will have this 0 to pi. Okay. Now, so we have x squared sin nx by n, this first term, and we have 2x minus minus plus, so 2x cos nx divided by n squared, and this becomes minus 2 sin nx by n cube. So now you have to substitute now upper limit. So when you are going to substitute the upper limit, this gives pi square, and we have sin n pi. Sin n pi is 0. Already we learnt sin n pi in the previous problems. We learned sin n pi equal to 0. So this term becomes 0. Okay. What about next term? Next term will be your pi. So this becomes, instead of x, you have to substitute pi. So 2 pi. Cos n pi. Cos n pi is nothing but minus 1 to the power n. Cos n pi. So minus 1 to the power n divided by n squared. What about sin n pi? Again it becomes 0. What about sin 0? Here it is, sin 0 is 0, whereas x is there. So this becomes 0. You have to substitute the lower limit. When you are going to substitute the lower limit, this becomes 0. And this becomes 1, whereas x becomes 0. So total term will become 0. Is it okay? See here, when you are going to substitute the lower limit, 2x cos nx. Cos 0 is 1, whereas x is there. So x equal to 0 means every term will become 0. So this term becomes, so that is 0. Here also 0. So only one term is left out. So we have 2 divided by pi, 2 pi minus 1 to the power n by n squared. So an equals 2 2s are 4, and your pi and pi get cancelled, minus 1 to the power n divided by n squared. So this is the expression for your an, another coefficient. So find the Fourier series of the function f of s equal to e power x within the interval minus pi and plus pi. So interval is given as minus pi and plus pi. F of x equal to e power x. So first we have to find out whether it is even function or odd function. So instead of x we have to substitute minus x. So f of minus x is equal to e power minus x, which is not equal to e power f of x. Okay. So it is not an even function, it is an odd function. Okay. If it is equal, then it is even function. It is not equal, so it is an odd function. So a naught equal to, we will find out a naught. A naught equal to 1 by pi times minus pi. The interval is given as minus pi to plus pi. So minus pi to plus pi. F of x dx equal to 1 by pi minus pi to plus pi e power x. Instead of x, you have to substitute e power x. So as it is in the problem. So we have e power x dx, which is equal to 1 by pi e power x integration, that will give you e power x itself. So e power x. Apply the limit minus pi to plus pi, that will give you e power pi minus e power minus pi. And I am going to multiply and divide by 2 here, because I know that cos x equal to e power x plus e power minus x divided by 2, whereas sin hs equal to e power x minus e power minus x divided by 2. So I am going to multiply and divide by 2. So that will give me, this term can be replaced by sin hs. See here, this term can be replaced by sin hs. So we have 2 sin h pi divided by pi. That is the answer for your a naught. Okay. What is asked? The Fourier series for the function is asked. Fourier series. So we have to find out now a naught, an, bn, and substitute in the Fourier series. So we have found out now a naught. A naught is given by this. See, in the problem, it is Fourier series is asked. It is not Fourier coefficients. Okay. But we have to find out the Fourier coefficients. Only then we can substitute in the Fourier series and get the answer. So first we have calculated a naught. Okay. A naught. So next we will go for an. An is the coefficient for cos nx. Bn is the coefficient for sin nx. So f of x is given as e power x. So we have 1 by pi times minus pi to plus pi integration f of x cos nx dx. So instead of f of x, we have to substitute e power x. So e power x cos nx dx. And of course, we know the formula we learnt just now, e power ax cos bx dx equal to this expression, where a is given as here e power x, a is given as 1. See, a is given as 1, whereas b is nothing but n. According to the formula, here e power ax, here e power x alone is given. So a is nothing but your 1, b is nothing but n. So we have e power x according to the formula, e power x divided by 1 square plus n square. Instead of a, you have to substitute 1. So 1 cos nx plus n sin nx, the limit goes from minus pi to plus pi. Now substitute the limit. So first we will substitute the upper limit. So that will give you e power pi. Then here it is cos n pi, correct? N sin n pi. Substitute the lower limit. So minus e power minus pi. See, e power minus pi divided by 1 plus n square. Substitute the lower limit, will give you cos minus n pi plus n sin minus n. Okay. Now we know that cos n pi is minus 1 to the power n. Sin n pi is 0. So this becomes 0 and we have minus 1 to the power n. And here cos minus n pi. So cos minus n pi, it's an even function. Cos minus theta equal to plus cos theta. So cos minus n pi is nothing but cos n pi, even function, which is equal to minus 1 to the power n. So instead of this, we have to substitute minus 1 to the power n, and of course sin n pi also is 0. So we have 0. So we have now two expressions, only two expressions. Other things and all become 0. So we have e power pi minus 1 to the power n divided by 1 plus n square, and here it is e power minus pi minus 1 to the power n divided by 1 plus n square. We can pull common terms out. I have written the same thing. We can pull common terms out. So common terms will be minus 1 to the power n. Here common terms will be, in the denominator we have 1 plus n square. So you have 1 by pi times minus 1 to the power n divided by 1 plus n square. Here it is e power pi, and here it is e power minus pi. Is it okay? Now multiply and divide by 2. So multiply and divide by 2 will give you divided by 2. So okay. So this can be written as 2 sin hyperbolic function, 2 sin h pi. Okay, this is called h, stands for hyperbolic function. So minus 1 to the power n divided by 1 plus n squared pi, 2 sin h pi. And now we have computed an, the another coefficient for cos x in the Fourier series. Now we will go for the another coefficient bn. So we will have to see, for Fourier series we need to have a0, an, bn. So bn is nothing but 1 by pi times integration minus pi to plus pi f of x sin nx dx, and f of x is nothing but e power x. So e power x sin nx dx. Okay, e power x. Substituting in this, instead of a you have to substitute 1, instead of b you have to substitute n. So that will give you this. So this is your standard integral. Okay, standard integral will give you this expression. Now you have to substitute the upper limit and lower limit. Substituting the upper limit and lower limit. So you have substituting the upper limit, that will be e power pi divided by 1 plus n square sin n pi minus n cos n pi, correct? So minus substituting the lower limit, will give you this one, e power minus pi divided by 1 plus n square sin n pi minus n cos n pi. And of course we know sin n pi is 0, cos n pi is minus 1 to the power n, sin n pi is 0, cos minus n pi is nothing but plus cos n pi, which is equal to minus 1 to the power n. Okay, now this can be simplified as this, because 0 we can remove 0 here. This can be simplified as this expression. Okay, correct? Now we can pull common terms out. Just taking the common terms, that will give you, we have minus 1 here, minus n is here. So minus n I have pulled out. Minus 1 to the power n, minus 1 to the power n I have pulled out. Divided by 1 plus n square times pi. The remaining term will be e power pi, e power minus pi. and of course multiply and divide by 2, that will give you 2 cos hyperbolic function, 2 cos h pi. Okay, so this is your Bn. So we have found out now A0, An, Bn. Substituting in the Fourier series. So this is your Fourier series. So we have found out now A0, An, expression for Bn. We have found out. You substitute in this expression, so that will give the Fourier series for the given function. So your f of x equal to instead of A0, you have to substitute 2 sin h pi. So 2 sin h pi divided by pi, already 1 2 is there. So I have cancelled out. Plus summation over n equals 1 to n. Instead of an, you have to substitute this, and this must be cos nx as it is. Plus bn, instead of bn, you substitute this, and 2 cos hx. This sin x, let it be like this. So this is the final answer for your Fourier series of f of x equal to e power x. Correct? So which is asked. We will have to find out the Fourier series for f of x equal to e power x. So we will have to find out the expression for your a0, an, bn, and substitute in the Fourier series. And substitute in the Fourier series, that will be the final answer. So f of x equals e power x, which is equal to this. Okay. Now we will go for the next problem. Find the Fourier series of the following function. So f of x equals 0, the limits n lies between minus pi and 0, and which is equal to k, the limit goes from 0 to pi. Okay, n lies between 0 and pi. So there are two limits given. One is f of x equal to 0, another one is f of x equal to k. So find the Fourier series. So we'll have to find out a0, an, bn. We'll have to find out. Okay. So this is your Fourier series. First we'll find out a0. a0 equal to 1 by 2 pi minus pi to plus pi f of x dx, which is equal to 1 divided by 2 pi. Now it is given as in this limit f of x equal to 0. In this limit the f of x equal to k. So I have separated minus pi to plus pi and separated to minus pi to 0, 0 to pi. See, I have separated the limits. Minus pi to 0, 0 to pi. What is f of x? In this limit it is 0. So I have substituted 0 here. What is f of x here in this limit? It is k. It is k. So f of x equal to k. Is it okay? Simple. So we have 1 by pi. This becomes 0. K is a constant I have pulled out. So x, after integrating, that will give you x. Substituting limit will give you pi. Okay. So that will be your pi. So 1 by 2 pi, 1 by 2 pi, k pi, that will give you k by 2. So a0 will be k by 2. Is it okay? Now we will go for an. An equal to 1 by pi minus pi to plus pi f of x cos nx dx. So again we can divide the limits, separate the limits, minus pi to 0, 0 to pi, and f of x equal to 0 in this limit. So I have written 0 here, and f of x equal to k in this limit. Say f of x equal to k here, and this becomes 0. Don't go for calculation of this one, and this one alone exists. So we have k I have pulled out. So k by pi cos nx, integration of cos nx, that will give you sin nx by n. So 0 to pi. So that will give you k divided by n pi, sin n pi equal to 0. So an equal to 0. Okay. Now bn equal to 1 by pi times minus pi to plus pi f of x sin nx dx. So again separate the limits, that will give you minus pi to 0 f of x, which is nothing but 0, plus 0 to pi f of x nothing but your k. So this becomes 0, only this term alone exists. So we have this term alone exists. So this term alone exists. So I have pulled k out, sin nx integration, that will give you minus cos nx divided by n 0 to pi. Substitute the upper limit, that will give you, substitute the upper limit, that will give you cos 0. Cos pi is minus 1, correct? Cos pi is minus 1, we'll see. Cos 0 is 1. So we have cos 0 minus cos n pi. So k divided by, I have pulled n pi out, substituting the limit, that will give you cos 0 minus cos n pi. Cos 0 is 1. So k divided by n pi, 1 minus cos n pi. Suppose if n is even, if n is even. If n is even, cos n pi is nothing but 1. So 1 minus 1, 0. So this expression is nothing but bn. So bn equal to 0. Suppose if it is odd, cos n pi equal to minus 1. See, cos n pi, if it is even, if n is even, then we can say that this becomes 1. If it is odd, this becomes minus 1. Minus 1 becomes, here already 1 is there. So minus 1 becomes minus of minus 1. So this becomes 2. So bn is equal to 2. Is it okay? 2 times k divided by n pi. 2 times k divided by n pi. So that's the Fourier series. So we have now a naught equal to k by 2, a n equal to 0, which we have found out. Can you remember? A n equal to 0. See here, a n equal to 0. And your bn will be 2 times, if it is odd, 2 times k divided by n pi. 2 times k divided by n pi. Substitute the limit, substitute the expressions. So that will give you a naught. Instead of a naught, you have to substitute k by 2. So you have k by 2. This becomes 0. This becomes 2k divided by pi 1 by n times sin nx. Okay. Your a naught will be k pi by 2. So your this becomes only a naught. It is not a naught by 2. This is a naught. So there's a mistake here. It is not a naught by 2. It is a naught for this expression. So a naught equal to k by 2. See, k by 2 plus 2k by pi sin nx can be expanded into sin n plus 1 by 2 sin 2x plus 1 by 3 sin 3x dot 1 by n sin nx. So we will go for the last section. We will wind up now. Before that, we will discuss about odd function and even function, which we discussed earlier. As I said, this is an even function. When I am going to substitute for x as minus x, that will give the same thing, f of x. F of minus x equal to f of x. So this is an even function. See, that means it's symmetry. See, even function, cos, this is your cos curve. This is your cos curve. So this is an even function. This is symmetry. See, look at this. This is symmetry about its y-axis. See here, f of x. This is an even function. This is also symmetry. See, symmetry on both sides. This is like a reflection. See. So this is the example for your even function. Even function minus pi to plus pi, that becomes 2 times of 0 to pi. Okay. A naught becomes here minus pi to plus pi. A naught becomes 1 by pi times 0 to pi, f of x dx. Okay. A n equals 2 by pi 0 to pi, and your bn becomes 0. Okay. For the even function, only cos term alone exists. Okay, even function. The Fourier series becomes only cos term alone. So Fourier series f of x equal to this term alone exists. This one and this term. So this is expression 4.1. Okay. So this is the expression for your Fourier series for the even function. For the odd function, the expression equal to f of minus equal to minus f of x. Okay, so we can't separate the limit. So here minus pi to plus pi as is equal to 0. So this becomes 0 means the coefficient a naught equal to 0. So there will be no a naught. A naught becomes 0. Okay, only sin term alone exists. Cos term becomes 0. Okay, for the odd function. So this is your odd function. Only sin term alone exists. See here, sin term alone exists. This is sin curve. Sin term alone exists. So this is sin. Okay, so this is for the odd function. And as I said, a n becomes 0, bn alone exists. So expression for your Fourier series f of x becomes bn sin nx. Okay, so, and of course bn, the coefficient for bn equal to 2 by pi 0 to pi f of x sin nx dx. So equation 4.2 represents the function f of x in the series of sine and is therefore known as sine series in the interval 0 to pi. Okay, so this is your summary. And f of minus x equal to f of x nothing but even function. F of minus is equal to minus f x nothing but odd function. Okay, we can write the limits as 2 times of 0 to a. Instead of minus a to plus a, we can write 2 times of 0 to a. Okay, And very important thing is, odd function multiplied by odd function is nothing but even function. Odd function multiplied by even function will be odd function. Odd function multiplied by odd function will be odd function, whereas even function multiplied by even function will be even function. For example, you just take x sin x. X is an odd function. Okay, x is an odd function. Sin x, again this is also an odd function. So odd multiplied by odd will give you even function. See here, cos squared is even function. Sin x is odd function. Cos x is even function. Odd and even, that will give you odd function. Examples are given. X squared is even function. Cos x is even function. Secant x is also even function. And these are all the expression for your odd functions like sin x, tan x, cosecant x, cot x, x cube, x to the power 5, x to the power 7. So those are all odd functions. Okay. As we discussed, cos minus theta equal to plus cos theta. Okay. So we will stop today. We will see in the next class. Thank you, students. Bye.